Sure. So I'll take the opportunity to follow up a little bit now during the open mic session about Paul Abel's question in terms of rapid. What does that mean? And I think the best answer I can give is that we're still trying to figure out what it means, in the sense that as Paul noted and as Lorian also noted, there's a number of things, there are a number of limiting factors at play, and they're not all the same thing. So there's the question of how quickly a launch vehicle could actually be provisioned for the mission and where it would come from. There's the question of how quickly could the spacecraft, either reconnaissance or mitigation spacecraft or a combination recon mitigation spacecraft, could be assembled, ready for flight, and mated to the launch vehicle. That's a question mark. We don't know how long that would take. And it depends on your prior assumptions, right? Is the spacecraft being built on demand? Is it partially assembled with some components in storage? Is the whole thing assembled in storage and it's sort of pulled off the shelf and reactivated? Those are all plausible scenarios, but none of them have yet been studied to the level of detail that would be necessary to really give a definitive answer as to what the timeline would really look like. So I think, we're sort of trying to bracket the problem. So in the scenario that we looked at this PDC, clearly going from, detection of a threat that rises above the impact probability threshold for action to launch in 12 days, that's certainly beyond the scope of what's practical right now. That's for sure. But then the question is, okay, well, when does it become practical? So in prior PDCs, we've looked at notional timelines from authority to proceed to launch of about 2 years. And, perhaps that's a lot more technically practical, but exactly what that would take still remains to be seen. So I don't know if that answers your question any better, Paul, but I think what I'm trying to say is that, we know that the fastest reliable response time is probably somewhere between those extremes that I just gave. And it's really an important future work item to sharpen the pencil on that and become more operational, but it's a work in progress.
Yeah, thanks, Brent. I think that's sort of getting to more of what I was trying to get at. I know this scenario was really challenging, and it was designed that way to give more emphasis for the emergency response folks, I think. But yeah, it's that operational piece. How do you do it and what decisions do you make when in order to get that process going? I mean, we know we have guidelines for when we're supposed to launch or consider when SamePage, for example, comes into play. But when you start saying, okay, we're going to do something and we're going to launch, how rapid is rapid? And that's what I'm trying to get at. And there's subtleties to looking at that, both from the standpoint of components, the spacecraft, the launch vehicle, and things that you just mentioned.
Thank you. Any other open mic issues to discuss?
If there's time, Mihai, I have another question for Brent.
Please, go ahead.
So, Brent, you're well aware of this, but in the National Near Earth Object Preparedness Strategy and Action Plan, one of the goals is to look at developing recon capabilities and so forth. And really this year, there was a new report from the working group that was looking at threat protocols and, set kind of criteria for when missions would be launched and so forth. Within the scope of implementing that plan, are you, as a group of people actively working on the kinds of analysis you talked about for the various parts of what a rapid capability might look like, or is that effort that's not currently being undertaken?
We are working on it. Kind of as we can. Everything you said is correct about the National Preparedness Strategy and Action Plan containing actions intended to address these very things. Preparing for a rapid response, studying what it would take to do reconnaissance, especially on a rapid timetable, and also to answer the other questions that Paul was raising, all of it getting towards, understanding what it would take to get to various levels of operational readiness and to respond, under various timelines, warning timelines. So that work is underway. We have done some work for our group at NASA Goddard Space Flight Center has done some work on looking at some candidate designs for what a rapid reconnaissance spacecraft might look like. That work's kind of ongoing, and we're hoping to be able to publish some results and share some results about that. But it is something we're looking at. The other thing that we started doing is we connected with the launch services provider folks at Kennedy Space Center for this PDC exercise to start talking about what it would look like to try to get ready for a rapid response launch. And so one of the new things that we did for this scenario that we haven't done in the past was we received a launch vehicle performance model that wasn't really specific to a very particular vehicle, which is the way we usually design these scenarios, but rather it was representative of kind of an intermediate class launch vehicle with a solid motor kick stage added to the top to give it extra, capability, and able to launch it even to very steep declinations and very high Earth departure energies. It remains to be, it's forward work to say, okay, well, how quickly could something like that really be stood up? That's still in progress, but at least, we're moving that way. We're starting to have those conversations and say, okay, well, here's a notional model you can use to get started. We didn't have that 2 years ago. So we're chipping away at the problem.
Thank you, Brent. That's useful.
Any other items for the open mic session? Thank you all for a very interesting day, and see you all tomorrow.
Mihai, there was just a comment in the chat.
Oh,
Yeah, I was just asking about the Common Interceptor mission of ESA, which is a very interesting idea that you position something out there to wait for a comet to come by that you don't know is going to come by, you haven't discovered yet, and then send a spacecraft to it. And it doesn't seem like that's technically that different from the problem here. One's a comet, one's an asteroid, different orbits and so on, but it's set, so that's a different solution. I don't know if it's been considered for asteroid warning, just to have something out there that could come and, be targeted at an incoming body. And then maybe after a decade, if nothing comes by, you do something scientific.
That mission doesn't have a nuke sitting on it.
No, but there was a discussion of reconnaissance missions here. And they wouldn't have nukes either, I don't think.
That's
If you don't have
right.
nukes, you gotta have the military involved. I don't see there's any way around that.
So there is. So I think this is a good point. It does raise the point that there's a synergy between the desires for rapid response, opportunistic, scientific interactions with objects, as well as reconnaissance for potentially hazardous objects. So in other words, the same kind of rapidly deployable system to do a flyby of a scientifically interesting object could just as well do a reconnaissance flyby of a potentially hazardous object on short notice. I think that synergy is an important point.
We've done a lot of thinking about interstellar asteroids, which require something like this if you're ever going to send something to them. And
Right.
it doesn't seem technically that different. It's different in ways, but not, not at a deep level.
Sure. You can envision the same spacecraft system doing both jobs, PHA reconnoitering and, flying by those kinds of interstellar asteroids and such.
so thank you again. At this point, I would like to bring this session to a close and see you all tomorrow.